This video is about the topic, the probability of selecting one card from a standard deck. Let's look at some examples. Here is a table that shows all 52 cards in a standard playing card deck. Let's look at it just for a moment before we answer any questions so that makes sure we know how it is built. There are 52 total cards and they are divided into 4 suits: hearts, diamonds, spades, and clubs. The hearts and diamonds are all colored red. The spades and clubs are colored black. For each suit, there are 13 cards: ace through 10, a jack, queen, and a king. And the special cards, jack, queen, and king, are called face cards. So this is how our deck is built. When you are asked to answer questions about this, you will have this picture that reminds you of how the deck of cards is built. So don't worry about memorizing this. Let's look at this example. Suppose we draw one card at random from a standard deck. Let's look at part A first. What is the probability that a card drawn is a face card? Okay. When we are looking at probability, and in this case what we're doing is drawing one card from this deck of 52 cards, each of the 52 cards is equally likely. And now what we want to know is, of all those 52 equally likely possibilities, what is the probability that we draw a face card? Well, let's look at our face card section. That's over here. All of these are face cards. So we see there are 12 possible face cards that could be drawn out of the total deck. So our probability that we draw a face card is the 12 face cards over the total number of cards. 12 over 52. Okay. We could simplify this. It does want your answer as a fraction, so don't simplify to a decimal. Don't get an approximation. Leave your answer as a fraction. But we could simplify. Both of these could be divided by 4. 12 divided by 4 is 3, and 52 divided by 4 is 13. So 3/13 is the simplified fraction. Let's look at part B. What is the probability that the card drawn is a red card? Okay. Well, again, we have 52 possibilities, so our denominator is 52. When we're doing probability and we have equally likely outcomes, the number of equally likely outcomes can be our denominator. For our numerator, we'll look for the number of outcomes that match the situation at hand. So here it's asking, what's the probability that the card drawn is a red card? So for that situation, we want to look just at these top 2 rows that contain all the red cards. Well, how many red cards are in each row? Each one contains 13 cards, so 13 plus 13 is 26. So the probability of drawing a red card is 26 out of 52, or we can simplify that to 1/2. Notice we may have been able to get 1/2 from the beginning because the way this deck is built, we see that half of them are red and half of them are black cards. Therefore, the probability of drawing a red is 1/2. All right. Part C. What is the probability that the card drawn is a face card or a red card? So now we have to deal with a couple situations. We're dealing with face cards and red cards together. So our denominator is still 52 because we are still dealing with 52 equally likely possibilities. But now we want to count how many are a face card or a red card. We'll switch to a highlighter for this. Our red cards, we have this first row and the second row. And that's all of our red cards. For our face cards, we have the last 3 columns. But notice some of them were already counted, so we want to be sure not to count those twice. But what we can do to count this is to see how many total things we now have highlighted. Each row has 13, so that's 13 plus 13 plus 3 in the spades row and 3 in the clubs row gives us 32 total. So 32 out of 52 is the probability that the card is a face card or a red card, one or the other, or possibly both. Notice these 6 cards right here are actually face cards and red cards, okay? All right, and if we wanted to simplify that, we could divide by 4. 32 divided by 4 is 8, and 52 divided by 4 is 13. All right, let's look at another example. All right, we have the same setup, so let's jump on into the questions. What is the probability that the card drawn is a club? Well, a club is going to be this last row here, the clubs row. Notice there's 13 clubs out of the total 52 cards. So the probability we draw a club is 13 out of 52. That simplifies to 1 out of 4, which we may notice we could have gotten realizing there are 4 different suits, each of them with the same number of possibilities, same number of cards per suit. So clubs is one of the 4 different suits that could be drawn, and each suit is equally likely because they have the same amount of cards. What is the probability? Part B, what is the probability the card drawn is a jack? Okay, well, still we know there are 52 total cards to choose from, and let's go and see how many are jacks. Well, we see jacks right here in this column. There is 1 jack for each suit, so there are 4 total jacks. So 4 out of 52. We can simplify this, divide both by 4, and we get 1 out of 13. Part C, what is the probability that the card drawn is a club and a jack? And we have to be careful here, that and. So again, we're out of 52 because there's 52 possible cards that we could draw from. But what's the probability the card is a club and a jack? So if we look, the clubs is the last row, and the jacks is this almost third to end column. But if it's going to be a club and a jack, it is only this one possible card, the jack of clubs. So the probability of drawing a club and a jack is just 1 out of 52. Let's look at one more example. Start with part A. What is the probability that the card drawn is a heart? Well, if we look at the heart is the top row, and there are 13 total hearts in that top row out of the 52 total cards. Or we could also say, remember from our discussion about the clubs, the heart is one of the 4 equally likely suits in the deck. So 1 out of 4 is the same as 13 out of 52. Part B, what is the probability that the card drawn is a face card? So now we want to look at just how many face cards there are compared to the whole deck. Again, we know there are 52 total cards. So what is the probability that the card drawn is a face card? Well, we can look here at the end. We have 3, 6, 9, 12 face cards. So 12 out of 52. We can divide that by 4 and get 3 out of 13. And now the last question says, what's the probability that the card drawn is a heart and a face card? So we need to see what the intersection is of hearts and face cards. So hearts is the top row, and face cards, we'll circle those, are here. Oh, hold on. Sorry. That was the intersection. The face cards are all of these last 3 columns. So where are these overlapping? That's these last 3, the Jack, Queen, and King of Heart. So there are 3 possible cards that are a heart card and a face card at the same time out of all 52 cards. So 3 out of 52 is our probability because there are 3 that meet the criteria, heart and face, out of the entire 52 cards.